Hello everyone, welcome to the Naughty Samurai channel, and in today's episode we are going to talk about the one-hot encoding. So what is one-hot encoding? One-hot encoding is a technique used to convert the categorical data into a numerical format that machine learning models can understand. And why do we use it? It's because most machine learning models cannot process text, they need numbers. The machine learning models cannot inherently understand the distinction and difference between each of the colors. It cannot process text, so what it does in order to understand the distinction between each of the color based on their specific characteristics is it converts the specific color into a numerical representation of numbers. So it converts the red color into a binary column of 100. Again, it converts blue into a binary column of 010 and then green into a binary column of 001. After this video, you will be able to understand what is one-hot encoding and how to apply this concept for your own dataset while working with a machine learning model. You will also be able to understand the difference between each one-hot encoding technique, be it ordinal encoding, label encoding, or categorical encoding. We will also see how to apply Scikit-learn for enabling the one-hot encoding technique. So let's get going. After importing all the necessary libraries and taking our dataset and storing it into a variable named data, we will print the last 10 rows of the dataset. Here we can see that there are many NN values that are present throughout the dataset. So what are these NN values? As we have seen previously, these NN values are just the missing data. And before progressing into anything, we first have to deal with them. We have explored a bunch of methods for dealing with these missing values in our previous video. So if any of you guys are curious about how to deal with these missing values, you can go check that video out. But right now, before progressing into the one-hot encoding technique, we will have to deal with these missing values. So how do we do that? Here we will apply the mode technique in order to deal with these NN values. What will the mode technique do? So mode technique will go to each of the specific columns. It will find the value that has repeated the most amount of times in the single column, and then that number or value that has repeated the most amount of times, it will replace all the NN values with that specific word or number. As we are exploring categorical encoding technique, we will specifically work with those columns that do not have any numerical values, but rather they have categorical values. So you can see here that price, rating, and discount all have numerical values in their rows. So we will ignore that because we are applying categorical encoding. So we will just work with category and stock. So let's deal with the category column first. So data category dot fill NA, it means it's filling the null values. And now what do we need to fill the null values with? Category, and here it could go mode score 0. Alright, and we also have to write in place is equals to true. So what this in place does is that instead of creating a new data set, it just works on the specific data set that we are already working with. So it does not consume much memory. Alright, now if we run it, alright, so now the NN values have been replaced within the dataset, and we would do the same exact thing for the stock column. You just have to replace category with stock. Alright, so this will become stock as well. Now we will rerun it again, and both these columns have been changed successfully. If we want, we can verify if the null values have changed or not. As null.sum. We run it, and you can see the category column and the stock column has now 0 null values. So now we can successfully proceed into working with the one-hot encoding technique. Now in order to move forward, we have to work with the getDummies method of the pandas library. First, we will separate the columns that we are working with. In order to do that, we will write sep data is equals to data, double parenthesis over here, name of the columns that we are working with, which are category and stock, and then we write sep data. We run it, and now you can see that the columns that we are working with are now separated. So now we can actually visualize and see what we have to do with this data. Right after this, we will apply the getDummies method of the pandas library on top of the separated data, and we will also have to include that data type and specify it to be integer, because if we do not do it, it will actually return us the true false values instead of the binary values, and we do not want the true false values, we want the binary values. So we will have to include the data type and specify it to be integer. So after we run this, we can see that the initial two columns, category and stock, have been divided into each individual sections. The category column have been divided into 4 sections and the stock column have been divided into 2 sections. So what is this data set consisting of binary values of 0 and 1 actually trying to tell us? So before we get into this, we will first print the first 10 rows of the data set. And okay, here goes our data set. We will do the same exact thing for here as well. And it will return us the first 10 rows too. So there is a connection between both these tables. And what is that connection? Here you can see that the category column A, B and D have values to be 0, starting from 0 up until the index of 6. But category C has the value of 1 starting from 0 up until the index 6. And why is that? It's because here you can see in the original data set, starting from index 0 up until the index 6, you can see the category type have been C consistently. Only starting from 7 to 8, the type changed to A, and again it started with C. So this is why you can see it just resembles this first 7 rows, and which is why you can see that here in category C column, the first 7 values are 1. And again here you can see for the 7th and 8th index, the value changed to A. So you can now see that the category C column for the 7th and 8th index has a value of 0, but category A has now 1, because here you can see the 1s over here. And again, starting from index 9, you can see it will shift to 1 and this one will become 0. And the same goes with the stock column. You will see that starting from the 0th index up until the 3rd index, the value was in stock. So in stock column had the value of 1, but the 4th index had the value of out of stock. So here goes 1 and it becomes 0 again. So it changes accordingly with the value that was here. So it just makes easier to navigate through the data set and helps to tackle specific values. And in future, if you want to drop any specific category, we can easily do that using this technique. Next, if you want to cross-check the data type of each of the columns, we can easily do that using pd.getDummies. Within the parentheses will be sepdata again, and at the very end we will call the info method, and this will return the total non-null count and the data type. So you can see all the data type of all the columns have been converted successfully into Boolean type, and you can see that all the columns have now 4, 3, 6 to non-null values consistently. So do you think it aligns with our initial goal? It doesn't, because our initial goal was to convert the textual content into numerical format or numbers. But are these numbers? They are not numbers because their data type is Boolean yet. All these 0 and 1 are still Boolean values, but they are not into numerical format. So we have to bring it to numerical format. And how will we do that? In order to achieve our goal, we have to use the Scikit-learn library. So we will first install Scikit-learn. It should take a minute, not more than that. After it's installed, we have to import One-Hot Encoder. We will run it and it's successfully imported. Next is we will create an object for this One-Hot Encoder class, and within the parentheses we will okay, we don't have to write anything within this. Alright, the object has been created, and the very next step would be to apply the fit transform method on this object, so the data can be fitted. Within this will be the sep data. I think this is it. We can run it. Alright, so it actually returns a matrix. So in order to make it visible, we have to convert it into array. So to array, and when we run it, now you can see it returns us an array of Boolean values, but it is actually not visually understandable. So we have to convert it into something that we can actually understand and keep a track of. So we will convert it into a pandas data frame. So we will first store this array into an array variable. We will run it. Next, we will call pandas pd.dataframe, and within parentheses will be array, and we will call all the columns that are needed. So there would be category A. Let me copy it from here. Category A. Category A goes over here. I will copy it and I will paste it 4 times. Okay, we will change it to B, C, and D. The rest 2 columns that are in usage are stock in, stock, and stock out of stock. So I will copy it here, paste it. Again, we will copy this one and we will paste it over here again. Okay, sorry. Alright, this is done. And now when we run it, now we can see that this have been converted into a pandas data frame, and all those binary values have now been successfully converted into numerical values. You can see these are all float values, so these Boolean values have now been converted into numerical format. So we have achieved our goal. Another way this one-hot encoding technique comes in handy is because we can drop a specific type of value from a column. For instance, if we want to drop this category A column all at once, we can easily do that after applying this one-hot encoding technique. How? Let's see. So we will create another object of this class. We will call it, and right after it we will apply the fit transform method on top of this object, and within parentheses will be the sep data, and as its initial format is matrix, we will have to convert it into array. And finally we will store it into the array variable all over again. And now when we run it, we can see the array values all over again. Now we have to convert this values into pandas data frame. But wait, we did not drop the first column yet. How can we do that? If you want to drop this specific column, we just have to insert within the parentheses drop is equals to first, and surround it with commas, and we will rerun it. Alright, so in the very next line, we will call this exact line over here. We will paste it and just change this ARR to R. And as the first column have been dropped already, we will have to remove this column. Now when we run it, what happened? I don't know. It should have worked. Stock in out, stock out of stock. Okay, so what's wrong with this? Okay, so alright, so how it works is that it's actually dropping the first column from both the initial columns. So it drops this category A over here and also the stock in stock over here. So this is how this method works. So if we remove the stock in stock, and then if we rerun it, it should work. And see, you can see that it works, and the first column, that is the sub column actually from the 2 initial columns, have been dropped successfully. So this is how it works. There might be some values that are actually holding the model back from achieving a better prediction, and the category A or the stock in stock might be that sort of value. You do not have to drop it over here. We will work with the initial values here, but you now know, like, if you want to drop some value, you can easily do that after applying the one-hot encoding technique. Next, what we will explore is the label encoding technique. So what is label encoding? Label encoding is actually exactly just as categorical encoding. It is a technique used to convert the categorical data into numerical format so that machine learning models can process them. And how does it work? First, before we get into it, we will import the pandas library again. And in the next cell, we will create our very own data set. Data frame, pd.data frame, and within this, we will let's say something like fruits, and then the name of the fruits can be oranges, apples, mangoes probably. I think that's enough. And alright, wait, okay, we have to declare the variable dataset is equals to pd.this, and then we will run the dataset. Alright, so you can see now we have our new dataset with just one column, that is fruits. So the next step would be to import label encoder from the Scikit-learn library. From Scikit-learn.preprocessing, we will import label encoder. Okay, now we will create an object of this class. Next, on the top of this object, we will run the feed transform method, and this will be dataset. We will have to declare the only column that is present over here, that is fruits. And now when we run it, we can see we actually get returned an array. So what is this array? So it's actually assigning values. It's actually assigning numerical values to our textual content. So it actually declared 2 for oranges, 0 for apples, and 1 for mangoes. And this was actually our initial aim. What if we insert another fruit named bananas, and we will run it again, and we will rerun it too. So now you can see we now have an array with 4 values, 3, 0, 2, 1, 3 assigned to oranges, 0 assigned to apples, 2 to mangoes, and 1 to bananas. So this is how the label encoding technique works. Now we want to change it into a dataset. So for that, we will write dataset new fruits, and we will just copy this one and paste it over here. We will run it, go to the new cell, we will call the dataset again, and now you can see this new fruits have been merged here, and all the values have been mapped to the textual content. So 3 to oranges, 0 to apples, 2 to mangoes, and 1 to banana. We can also apply this exact same concept to our initial dataset that we used here, which is this one. Let me show you how. So we will initiate it all over again. Let me call this. Alright, so this is the dataset. Where is it? Okay, this is the dataset. We copy it. We come back here, we paste it, we change its name to data instead of data. Alright, now this will become this too. Alright, so this is our new data set, which is untouched and unmanipulated. So now we will work with it. So first, let's deal with the stock column. Now first, we know that before progressing, we first have to deal with the missing values. So we will here apply the mode technique as well, all over again. So data, okay, data stock and dot mode 0. So in stock is the value that is repeated the most amount of times in this column. So this is our mode. So we will replace all the n values with this value of in stock because this is our mode. And in order to do so, we will write data stock, and we will fill the null values with data, and here it goes stock. Just copying this exact same thing that we wrote. Alright, and finally we will declare another parameter in place equals to true. So we know what it does. Instead of creating a complete new data set, it just replaces the original one. So now when we run it, this thing have been applied. The NN values have been changed now. To cross check it, we will just run the data set, and we will see that now the NN values that were present over here have been removed and have been replaced with in stock. So now, as we have already called the label encoder class before, we will create another object of this class named, now let me call it lnn is equals to label encoder Okay, label encoder, and now we will apply the fit transform method again, but now it will be on top of the stock. This will be data. Alright, we can run it. So you can see it's now returning an array again. This is what we wanted. So it's actually assigning, probably it's assigning 0 to this in stock value over here, and it's assigning 1 to out of stock. So see, we are now getting our label encoder, and what if we want to replace it over here? We can absolutely do that. How? It's very easy actually. We just have to write data stock equals to, we can copy this line over here and paste it, and we can run it. Now when we call the dataset all over again, you will see that those in stock and out of stock values have been now replaced with the value of 0 and 1. So it's actually mapping 0 to in stock and out of stock with 1. So it's as easy as it can get. So I hope you guys are in sync with me and what's going on over here. So so far we have covered the concepts of categorical encoding, and we are also done with the label encoding. So the last remaining concept that is left with is ordinal encoding. So now let's get into that. What is ordinal encoding? So ordinal encoding is a technique that we use to convert the categorical data with an inherent order into numerical values. So the catchphrase here is this word inherent order. So what is this inherent order that we are talking about? Previously, when we used categorical encoding and label encoding, the columns in the dataset did not follow any specific order. So the type of order that I'm talking about, I think you will understand it more clearly when I show it to you visually. So for that, I've created a dataset. This is the dataset, and then I will call this dataset. And so this is our new dataset, and it actually lists different sizes. There are 4 main sizes over here: small, medium, large, and extra large. And it just gets it keeps repeating again and again. So in total there are 12 rows over here, and we are going to manipulate this dataset and apply ordinal encoding technique over here. So the type of order that I'm talking about is, see, the values range from any of these 4 values, from either small, medium, large, or extra large. So it's actually following a specific order. It's not out of order. You cannot just put any other value. You cannot put oranges over here. It's following a specific value, and in some sort it's also following the multinomial classification. So I hope you get an idea. So if you ever encounter any data set which have a column like this, you eyes closed, you can apply ordinal encoding. So now let me show you how ordinal encoding is applied to these concepts. So first, what we have to do is we will import ordinal encoder from the Scikit-learn library. Ordinal encoder. Okay, we will run it. Next, what we will do is we will create an object of this class, ordinal encoder, and within this we will have to declare the categories. So like what we have to specify in this category section, we will create another cell. Now you will understand the order. You can see that there are either 4 values. It can either be small, medium, large, or extra large. So we will copy these 4 values. We will create something else, that main data. We will create this variable, and within this we will take a list and paste it over here. This will be actually within double parenthesis. Alright, it's done. No, okay, yeah, it's done. We will run it. Now we will just pass this main data that we created as parameter, and now we can run it. Alright, so the next step would be to apply the fit transform method on top of this object, and within this parenthesis we will declare data to the only column that we have, that is sizes. We will run it. Okay, there goes an error. So fit transform data to sizes. This should have worked. I think there will be parenthesis. Okay, we can rerun it. Okay, now it's returning us an array, and we know what we do when we get returned an array. We have to change it into a pandas data frame so that we can actually visualize what is it telling. So for that, wait, before, okay, you get it. Now let me create new sizes, and we will just transform it and write it over here. All right, and now when I run this, okay, now when I run this, you can see a new column have been added with the new sizes. So it's actually mapping the values from the text to this new value. So 0 has been mapped to small, 1 has been mapped to medium, 2 has been mapped to large, and 3 has been mapped to extra large. So this is the whole concept of ordinal encoding. It works on the data which follows an inherent order, and you can see this has been following an inherent order, and we applied the ordinal encoding technique to map this text to this values over here. So this is it for today. I really hope that you guys enjoyed the video and understood the concepts well enough to hit the like button and the subscribe button before leaving, because this keeps me motivated to bring in more content, and more videos will be coming up this week, and I'm super pumped up to complete this machine learning Blackbelt series anyhow. So up until then, keep your mind sharp, your code clean, and stay sane. The Naughty Samurai signing off.